Welcome back everyone to another Khan Academy tutorial on West Explains Best. I am Mr. West and this is the quadratic formula. So in order to begin, we need to understand, wrong button. We need to understand what the quadratic formula is. The quadratic formula is a way that we can solve any quadratic in this form without having to factor or any of that stuff. Now in order to solve for x, which is obviously here and here, there's a formula which I'm not going to go in the how to derive it in this video, but we know that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So here's the issue. The number one problem people have with doing the quadratic formula or applying the quadratic formula is finding the accurate values for A, B, and C. So we're going to do that first. In order to get the accurate values of A, B, and C, we need to get everything equal to 0 as it suggests in this original format, this standard form here. The issue with this problem is we have 9 plus 7x on one side of the equal sign and 7x squared on the other. So what we need to do first is subtract 9 and subtract 7x from both sides. So then it should look like this. It should look like 7x squared minus 7x minus 9 is equal to 0. Once we have this, it's much easier to see A, B, and C. So A is always the coefficient of the x squared term. So in this case, A is 7. B is always the coefficient of the x term. In this case, it's negative 7, and then C is negative 9. It's the number by itself. Now it's just a matter of plugging in those values. So we know that x equals, and now we're going to put in negative b. This is where people make a mistake often. They think that if b is already negative, then they just leave it how it is. That is incorrect. What we're going to do is we're going to make it negative, and then we put this negative 7, that's our value for b, in parentheses. That way we're going to change the value of b. You're always going to change the value of b, essentially. Okay, so then we have square root. Then we have negative 7 squared. I'm running out of room quickly. Minus 4, and then a is 7, so we're going to multiply this by 7, and then multiply it by negative 9. Oof, cutting it close. All over, I think it's 2 times 7, right? 2 times 7. Okay, let's simplify it step by step. That way we don't make any mistakes. We have negative 7. It gives us a positive 7 plus or minus the square root of 49. And then we have negative 4 times 7 times negative 9. So it's going to be a positive number. So we're going to be adding. So we have 9 times 7 times 4. And that gives us plus 252 all over 14. So I'm going to add 252 plus 49. I get 301. Negative 7 plus or minus 301 all over 14. Oh, forgot the square root. Now, does 301 have any, can we factor it at all? It can't be divisible by 2, but we can try some other prime numbers. It's not divisible by 3 because the sum of the digits is not, it's not prime. Oh, this is not negative 7, by the way. This is just positive 7. I don't know why I copied it down. My mind got incepted by this influence right here. Okay, right now I'm leaning towards this option D, just because you could add negatives to the top and bottom and it wouldn't change the value. But let's just double check that. This is a way that Khan Academy makes these problems a little bit more difficult. Divided by 7 is 43. 43, so hold on. What I'm doing right now is I'm just checking to see if we can reduce the square root of 301. And I see that it's divisible by 7 and we get 43. Unfortunately, 43, I believe, is a prime number. I don't think you can divide it by anything else. 43 divided by... No, it's not divisible by anything else. So 301 is, it's not prime, but it can't be reduced any further. So what we're going to look at here is if we added a negative to the top and a negative to the bottom, it wouldn't change the value of the problem. So we are just going to choose option D because that's what matches up with ours. Okay, moving on. Now we have 6 plus, we got all this stuff. We need to get everything over to one side first, so we're going to subtract 2x squared. Now, I guess it would make more sense to subtract 8x squared. I mean, either way, I usually like to have the a positive, but it doesn't really matter that much as long as you input everything correctly. So I'm going to subtract 8x squared from both sides. So then I'm going to put it in standard form, which is the x squared first, the x term next, and then the constant last, and set that equal to 0. So now I need to identify my a, b, and c. This is the most important step. My a is going to be the number in front of x squared, which is -6. My b, -3, and then my c is +6. So then I do negative b, negative, and then my b is -3, plus or minus the square root of b squared, -3 squared, minus 4 times a, which is -6, times c, which is +6. Anytime you have two negatives multiplied here, you're going to end up adding. So that's something to keep in mind. So we're going to add there. And then we have all over 2 times a, which is -6. Let's simplify. -3 gives us +3, plus or minus the square root of 9, plus, we already determined it's plus, and then we have 6 times 6 times 4. Times 4. So that's 144. All over -12. Simplify further, we have 144 plus 9 is 153. That's quite an ugly number for a radical, at least. 8, 9. I think it's divisible by 3, and it is, but it's 51. So I'm just trying to see if I can simplify 153, and if I divide it by 3, I get 51. I don't think, 51 is divisible by 3, which is 17. So what does this mean? That means we can, if there's 2 of a 3, that means we can factor 1 out, and the 17 stays home. So this is equal to 3 radical 17. So that's something to keep in mind, because I didn't see any radical 153 up there. So on a -12, as we suggested, this can be simplified to 3 plus or minus 3 radical 17 over -12. If you notice, all 3 of these are divisible by 3, so we're going to divide by 3 to all those terms. So we get 1 plus or minus radical 17. You could put 1 radical 17, but it's the same thing, divided by -4. And as you can see, that is option C. So I just wanted to highlight that, I don't want to do another one just for the sake of time, but I just wanted to highlight that you just got to move this over, find your A, B, and C. Make sure you simplify radicals, make sure you square things appropriately, make sure when you have a negative b that you're applying it correctly. And those are just really some of the basic keys to the quadratic formula. Otherwise, it's a little tedious, yes, in terms of simplifying and making sure you do everything right, but it's not that bad in terms of applying mathematical knowledge. So I hope this was helpful, and I'll see you next time on Wes Explains Best.